Welcome everyone to this explainer. Today we're diving into some absolutely mind-bending territory. We're going to break down a really fascinating 2026 paper by Daniel Correa called Beyond Einstein. And basically, we'll be unpacking this wild theory that the universe we live in, well, it might not actually be the unified single rulebook system we've all been taught in school.
But, before we even look at the data, let's just sit with a pretty radical question. What if space and time literally aren't real? What if the very fabric of reality that you and I move through every single day is actually just an illusion, just a measurement tool created by the human mind?
Okay, so here's our roadmap for today. We're going to cover 1. Einstein's universal map. 2. The space-time illusion. 3. Anomalies and earthly bias. 4. The alpha dipole mystery. And finally, 5. Welcome to mosaic physics.
All right, section 1. Einstein's universal map.
Imagine this for a second. If you were to completely clear out all matter and energy from the universe, take away every star, every galaxy, every single atom, what's actually left over? Well, according to classical physics and Einstein's theory of general relativity, you're left with this invisible stage. You're left with space-time. Science has pretty much always taught us that this space-time is a physical, bendable fabric where the whole movie of the universe plays out. And crucially, the assumption is that the rules of this stage apply exactly the same way absolutely everywhere.
So, this whole idea relies entirely on something called the uniformitarian principle. Basically, it's the assumption that the laws of nature are perfectly identical and homogeneous everywhere across space and time. Think of it like a local neighborhood regulation that we just automatically assume applies to the entire cosmic city. If a physics rule works here in our solar system, we just assume, hey, it must work exactly the same way in a galaxy billions of light years away, right?
Section 2. The space-time illusion.
Now, this brings us to a massive core debate. The universal model argues that space and time are real, tangible, physical entities that can actually stretch and warp. But there's this revolutionary alternative we're looking at today. What if space and time are literally just metrics, just completely abstract mental tools that humans invented so we could measure the distance between things?
Correa actually categorizes this fundamental split by suggesting that insisting on a universal space-time might honestly just be a historical thought bias. The mainstream institutional view strictly treats space and time as real entities, but it might just be a mathematical approximation, one that works absolutely wonderfully for our immediate solar system, but totally falls apart when we try to look further out into the deep universe. And the consequences of these two different views? They are massive. Because if space and time are a universal fabric, then geometric laws have to be identical everywhere. But if they're just human measurement tools, then physical interactions can actually change depending on your region of the universe. The fundamental rules of physics might literally be different depending on where you're standing.
Section 3. Anomalies and earthly bias.
So we are going to look at 3 major astrophysical anomalies that are really starting to challenge this dogma of a uniform universe. First, altered clocks. Second, transit variations. And third, the alpha constant.
Okay, let's talk about the clocks. It is a proven, measurable fact that atomic clocks on GPS satellites actually run faster than clocks down here on Earth. Now, Einstein's model says, aha, physical time itself is dilated because the fabric of space-time stretched. But Correa points to a completely different, totally valid reading that was actually first proposed by physicist Hendrik Lorentz. What if time didn't stretch at all? What if the local energetic and gravitational conditions out there in orbit simply alter the physical behavior of the cesium atoms inside the clock itself? It's a subtle shift, but a massive difference. We might literally just be measuring how physical matter reacts to local environments, and not time itself bending.
Which actually builds right into our second anomaly, transit variations. Under that uniformitarian principle we talked about, we can predict a solar eclipse in our own solar system a decade in advance with just perfect accuracy, mostly because we're playing a home game. But when we try to predict planetary orbits in incredibly distant places, like the M51 galaxy, we get what are called transit timing variations. The planets just don't show up when our math says they should. Now, mainstream science usually just assumes invisible planets must be messing with the gravity. But what if the math is wrong simply because the laws of gravity operate differently in that distant neighborhood?
Section 4. The alpha dipole mystery.
I want you to consider the number 1 over 137. This is the fine structure constant, generally known as alpha. In quantum physics, this number is basically sacred. It dictates the strength of electromagnetic interaction, atomic rigidity, and exactly how light interacts with matter.
If this number changes even a tiny microscopic fraction, stars couldn't fuse elements, and the chemistry required for life wouldn't even exist. We have always assumed it was perfectly immutable.
But an international team led by astrophysicist John Webb looked at the light from incredibly distant quasars and found something honestly chilling. They found a spatial dipole. The actual value of alpha changes based on cosmic direction. In one direction of the deep universe, it's slightly smaller, and in the exact opposite direction, it's slightly larger.
Think about what that means. If fundamental constants vary by direction, it means physics and chemistry literally change by region. This is a total bombshell. The universe is not a homogeneous plane. The specific rules that allow life-sustaining chemistry to even exist might literally only work in our specific cosmic neighborhood.
Section 5. Welcome to Mosaic Physics.
Look, classical astrophysics has a really major problem on its hands. To make Einstein's math work on a grand cosmic scale, scientists have literally been forced to invent concepts like dark matter and dark energy. These are completely invisible, completely undetectable ingredients that supposedly make up 95% of our entire universe, meaning only 5% is the visible matter we can actually see, touch, and interact with.
The mainstream approach just keeps blindly adding more invisible dark matter to the mathematical fabric just to force the old equations to work. But an alternative view, something like modified gravity, or MOND, suggests a totally different path. Instead of inventing invisible matter, we should maybe just accept that on massive, cosmic scales, the laws of gravity simply change.
Obviously, this requires a massive philosophical shift for all of us. We're talking about moving from absolute realism, which is the Copernican idea that our local solar neighborhood rules uniformly govern the entire universe, to concepts like relationism and emergence. And this is the idea that space and time are really just a mental map we drew, and the real universe is incredibly adaptive, with laws that emerge locally based purely on their specific environment.
So we are effectively trading in a single, rigid map for a dynamic, decentralized mosaic. Our earthly rules aren't wrong necessarily, they just aren't absolute everywhere.
As Correa's paper perfectly summarizes, quote, "The universe out there does not appear to be a single, rigid, centralized stage, but rather a dynamic, decentralized mosaic of local laws." Being skeptical of scientific dogmas isn't anti-science. Honestly, it's exactly how we discover the true fabric of the cosmos.
So I'll leave you with this final thought. If the laws of physics really are just local neighborhood regulations, how does that change your view of our exact place in the cosmos? Does it make us feel smaller? Or does it make the universe infinitely more mysterious and exciting? Thank you so much for exploring this mind-expanding explainer with me. Keep questioning, keep learning, and I'll catch you on the next one.